Welcome to my projectbazaar.com. Let us discuss about the optimal source and relay design for multi-user MIMO, AF relay communication systems, direct links and imperfect channel information. Let us discuss about the abstract of the product. So, multiple input and multiple output, that is a MIMO relay communication has attracted much research interest in recent years for its advantages in increasing the coverage and the capacity of wireless networks. So, in particular, the amplify and forward, so that is a AF relay strategy, has been extensively investigated in the literature. So, as it's simpler to implement than the other relay strategies. So, in the proposed work, statistically robust design for MIMO, so that is a multiple input and multiple output, has a multi-user relay systems with direct source to destination links and imperfect channel information, so that is a CSI. The minimum mean square error, so that is a MMSC, of the signal waveform estimation and the destination node is adapted as the design criteria. So we developed the two iterative methods, so that is a tri-stable and the bi-step. So these are the two iterative methods to solve the non-convex joint source relays and receiver optimization problem. So the simulation results demonstrate the improved robustness of the proposed algorithm against the CSI errors. So the CSI error means that is a channel state information errors. Finally, we calculate the BER and the MMSC of the value. Let us discuss about the flow diagram of the product. So this is the overall flow diagram. First of all, consider the system model and as the robust MIMO relay design, and then the two iterative algorithms, that is a tri-step and bi-step algorithm, and then it's converted to extension to multi-user MIMO relay systems. In this extension to multi-MIMO relay systems has multiple relay system are calculated, and then the performance analysis. Finally, we calculate the BER and the MSC all of the value. So in the system model, we consider a two-hop multi-user MIMO communication system. So where k users, that is a node I is equal to 1 to k. So transmit information to the destination node with the 1/3 of the relay node. So that is a single relay. The ith user is equipped with NSI, so that is a I is equal to 1 to k antennas. The relay and destination nodes are equipped with NR and the ND antennas respectively. Using a hop duplex relay communication process is completed in 2 time slots. During the first time slot, the NBI cross 1 modulated signal vector SI is linearly product at the ith user by source precoding of the precoded signal vector of the process is transmitted to the relay node and the destination node. So we denoted the NB is equal to summation of I equal to 1 to up to k. The total number of independent data streams for all the users. The received signal at the relay node is a YR. So that is summation of I is equal to 1 to k, that is a H1I, Xi and the NR. So the Gaussian vector at the relay node respectively. So the received signal at the destination node at the first slot can be calculator. So then proposed robust MIMO relay design. So this is the algorithm. In this section we developed the two iterative algorithms, namely tri-step algorithm and the bi-step algorithm. So in the tri-step algorithm, the source, relay and receive matrix are optimized iteratively through the solving the convex subproblems. So in the bi-step algorithm, the optimal receive matrix is substituted into the objective function. So we obtain an optimization problem only with the source and the relay matrix. So then the source and relay matrix are optimally alternating. The receive matrix is calculated after the convergence of the algorithm. So we calculated the two iterative method for solving the tri-step and bi-step algorithm and the receive matrix of the problem. So the extension to multi-user MIMO relay system calculate the multiple relay systems of the product. So the source and relay matrix are optimized, alternating the receive matrix is calculated, and the convergence of the algorithm of the process. So in this section, extension to multi-user MIMO relay system with multiple relay nodes. So we extend the proposed tri-step and bi-step algorithm to multi-user MIMO relay communication systems with direct links and multiple relay nodes. So we consider the system with k users and L relay nodes and one destination. So the signal vector received at the L relay node at the first time slot. We calculate the MIMO channel matrix between the L relay node and the ith user. We calculate the signal vector received at the destination through the direct links of the first time relay of the start. So we calculate the relay nodes of 2 L, and then we calculate the performance analysis of the BER and the MSC of the product. And then performance analysis, we study the performance of the proposed robot source and relaying pre-coding matrix design algorithm for multi-user MIMO relay systems with direct source destination links and the imperfect CSI through numerical simulation. For the simplicity, we consider the system with two users where all nodes are equipped with multiple antennas. So the extension to the system with k greater than 2, that is a straightforward, to visualize the flat relay fanning channel environment for notation simplicity. We saw the setup of channel matrix in a single relay, which can be easily extended to the system with multiple relay nodes. Finally, we calculate the BER and MSE of the particular MIMO relay system. So the BER is a bit error rate and the MSE is a minimum mean square error. So these are the overall flow diagram of the. Let us discuss about the running procedure for the product. So click the main file and then run. So it's time to run the procedure. So all the graphs are related to a flow diagram. So first of all, the first diagram, the system model. In this figure, the k number of users are hosting in the user group. So the star is denoting the k number of users and the NR is a relay. So single relay system is using in the first system model, and in the end it's a destination node. So in the destination node, it's also a single node. There are two types of two-hop communication. So first of all, the user send to the relay and then the relay is sent to the destination. So there is a one hop of communication. And the other one of communication is a directly send the information to the destination. So that is a link is denoted the direct number of destination. So the end is a destination. So the system about the k number of users. Here we consider the two number of users, the first user and the second user. Here k number of users. So n is equal to I2 up to k. So the NR relay is a single relay we use in that first figure, and then the extension work we use the multiple number of relays in the specific figure. So the overall system model is the process. And then the next figure, there is a BER versus SNR. So that sigma is equal to 0.01 and delta SNR is equal to 10 dB. So we compare the performance of the following 5 systems. So that is a non-robust design using the pseudo match and forward algorithm. So that is a PMP, and the proposed robust design using the bi-step algorithm. So that is a robust of bi-step, and then the proposed design of using the tri-step algorithm, and then the bi-step algorithm with the exact CSI knowledge. So that is a standard state information, and then the tri-step algorithm with the exact CSI knowledge. So that is a CSI of the channel state information. So we finally calculate the SNR of the value. So the black is denoted the pseudo match and forward algorithm, and the proposed using the bi-step algorithm is denoted in the red star, and the tri-step algorithm is indicated in blue, and an exact CSI. So that is a channel state information of bi-step. So that is including the red, and the exact CSI of the tri-step including the black. So finally calculate the BER and the SNR. So BER is a bit error rate of the overall process. Sigma is denoting the 0.01 of the delta SNR is equal to 10 dB of the process. In this figure, similarly the same process, only using the sigma is equal to 0.001 and the delta SNR is equal to 20 dB. In the previous graph, we discussed about the delta SNR is equal to 10 dB. So in this figure, the delta SNR is equal to 20 dB. The same process, the performance analysis comparing the all 5 systems to calculating the final BER versus SNR graph. In this figure, we calculate the MSE versus SNR. So the mean square error versus SNR. So that is equal to noise ratio. Sigma is equal to 0.001 and delta SNR is equal to 20 dB. We compare the performance of the following 5 systems. So that is a PMF and bi-step and tri-step for robust, and the exact CSI for bi-step and the tri-step. So we calculate the MSE for overall the process of delta SNR is equal to 20 dB of the process. Similarly, the same process, MSE versus SNR calculated for 0.001 and delta SNR equal to 30 dB, and the next graph is equal to delta equal to 40 dB. Calculating the 5 systems of the proposed system, the performance calculated with the matched and forward algorithm, and then the bi-step and tri-step with the exact and CSI for the knowledge. Final graph, BER versus SNR. So that is sigma equal to 0.01 and delta SNR equal to 20 dB without the PMF. So that is a robust bi-step and only for non-robust bi-step, and the non-robust PMF and the exact CSI of the bi-step of the process, calculating the SNR graph versus BER. So these are overall the running procedure for the product. Thank you for listening this video.